Hi, everyone. Thanks so much for coming. My name is Karen Huaulme. I am a principal developer advocate at MongoDB, and I'm based out of Austin, Texas. Are there lots of Americans here? I know Lauren's here. We just got me and Lauren, and we used to work together too. So I am so thrilled that you're here to join me for this talk about building search into your applications. So the way is, I have this, the game plan for Game Changer is I'm going to talk about why you need search inside your applications. And then we're going to talk about some of the sort of critical pieces that very successful search applications use, all the successful search applications use. I'll talk about Lucene, I'll talk about analyzers, then we'll start building out search queries. This session is going to be a lot of hands-on computers, showing you different things, showing you different code, exploring different features that you can achieve to get the best search results for your users. I'll talk about architecture and performance, because of course I can't talk about changing the game without talking about performance. And as I mentioned, we're going to be doing a lot of demos and a lot of online resources that I'm going to show you that you could share as you build out your search journey. But all of this is a bit tunable, so just so I understand where I should go with this, who here uses MongoDB already? Okay, great. And then, okay, so I'll talk more about that. And then who, are you guys already doing search? Are you interested in starting? Okay, great. Okay, great. Well, then we'll see. But this is tunable, so let me know. The one thing that isn't tunable is I've created this with a soccer theme because I'm from Texas and I don't really know soccer very well. So I created this demo. I found this data set. It's better than a to-do list, I guess. At Atlas Search, I've created atlassearchsoccer.com. So if you go on this on your laptops, you can play along with it. So let me show you what that looks like. So here is that demo. I found a data set, the FIFA player data set. It has 20,000 players in it. And so in it, everybody gets their own team because it writes to local stores to get these players. And you can find a player that you want, and you could look for him in different ways. So I always look for Mbappe because he's my favorite. But this website will show you how to build out these queries. And then if you want him on your team or anybody on your team, you could look at him, you could understand him, find other players. And if you like him, you just heart him, and he's written to your team. So I wrote this before the World Cup because I was like, maybe we could do Final Fantasy with the World Cup, but I've never played Final Fantasy. I mean, football fantasy football league, so it didn't really work for that, but it was still a fun little project to work on. So I'm sorry I keep calling it soccer. I'm going to try to call it football, but I keep forgetting because this is what we call football in Texas. And the reason I wrote this application is because my spouse is actually French, and my first husband's actually German. So my German son and my French daughter, they all talk about soccer together, and I feel very, very, very left out. But because France is so successful, it's just always on in the house, and so I'm just cooking for them while they play. So I thought this would be kind of fun because when they talk about players like this, I don't even know, I can't pronounce their name. Aubameyang, I think I'm pretty good at saying now, but I can't pronounce their names. They've got different characters. I wouldn't even know how to Google it. So this is kind of a fun thing. If you guys know soccer, if you want to find some of these players in this application based on the operators and how to do it, then this is a good way to do it. Real quick about me, that was personal. Professionally, I was at Amazon before. I've been at MongoDB for 5.5 years. I was at Amazon before, Twitch, and NVIDIA, solution architect, integration engineer, whatever. But today I am going to be your coach. So today I'm going to be your search coach, and we're going to play the search game, and I'm going to coach you on the strategies that you need to implement to be successful at search. So I'm going to put on my training jacket. I've got props and everything. I'm going to try and mix it out. Let's see if I can actually blow the whistle. I don't know. Sorry. And I'm going to put on my coaching hat. And now let's get started. So If you have users and you have data, you need your users to access your data. Salesforce says that 87% of shoppers start their search journey in a search bar. And Forrester says that 68% of those shoppers will leave if that search bar and not come back to the site if it's a poor experience. So you need to get this right. Now, this search bar, it looks easy, but on the other side of that search bar are users. So don't let looks fool you, because users are complicated. They don't know what they want. They don't know how to ask for what they want. They don't know how to spell what they want. And sometimes they don't even know that they're looking for something. So I'm going to teach you, if we can get them to find what they want, that means you're winning at the search game. And when you play the search game right, then that search bar turns into this. It turns into a giant goal, a goal so big that all of your users will find what they're looking for if you're playing it fast, and they'll find even things that they didn't know they were looking for. So playing the search game right means you get more likes, more shares, more users, and more revenue. But in order to play the search game right, you need to know that you're playing with the right equipment. You need to have the right players on your team. So the first player you need is documents. Search goes really well with a document database, because if you're playing the search game, then your users are probably looking through volumes of structured, of unstructured, and semi-structured data. Now, relational databases do really, really well when you know the queries ahead of time, what it's going to be. Rows and columns would be pretty good at that, but they're historically really, really slow for search. Documents are really great for this because they are flexible and they are fast. Because of how they store data, where all the data that you access, it saves time going to disk reads and stuff. We store data. Basically, it's keys and values, but the values can be anything. The values can be other objects. The values can be arrays. The values can be lots of things. So we're flexible like that. You could have your schema, but they're also dynamic. So you're having this search player on your team who's fast, flexible, and dynamic. And so you really need, if you're doing search, you need to be working with documents. Now, that player sets the ball really nicely to our next MVP, our search MVP, which is not this guy, and it's not this guy, maybe it's this guy, but it's this guy. In search, Apache Lucene is your MVP. All the winning teams play with Apache Lucene. You've got Walmart, Netflix, eBay, they all play with Apache Lucene, and with good reason, because Apache Lucene has been around for decades. It's tried, true, it's open source, it has everything that you need. So you can spend, and we've seen companies try and build their own search engines, but I like to think, why would you spend time and energy farming a potential promising young player when you've got Messi already warmed up and eager to play for you? So Apache Lucene actually has one nice power play. The documents feed into Apache Lucene through a process called analysis. Analyzers will take your document data and will cut it up into different tokens. And those tokens, terms are tokens. Those tokens are then stored on your inverted index. So this is what makes Apache Lucene so valuable. Now, once those terms and tokens are on your index, it also stores things like which documents those were found in, the frequency, position, and any other sort of metadata like that. So it's helpful because rather than looking at every document, if you're looking for something, the query, it'll just look at the index first. So you could think about an inverted index, like the index at the back of the book. I like to think that if I'm looking for, I just had my hair done today. I like to think that if I was looking for out, damn spot in the entire works of Shakespeare, I wouldn't read every page to find it. I would go straight to the back of the book and it would tell me what page it was on, and I would go there. So that's what you could think of when you're thinking of an inverted index. It maps back to the original index. So you know that inverted indexes are great for search, and you also may know, if you know indexes, the balancing B-tree indexes are really great for queries. So what's the difference and how do they work together? I can explain this real quickly through a sort of example. Let's look at a practice play, shall we? In these MongoDB documents, I have different football team names. I have Manchester United, Manchester City, Newcastle United, and Paris Saint-Germain, just because I got to put Paris in there. And then they have their unique identifier in MongoDB. If I were to look through those documents for Manchester United, the default index is the standard Lucene index. It's going to lowercase everything, remove the punctuation, separate at all the non-letter characters, and it's going to leave us with these following tokens, Manchester and United. So now, if I put Manchester United in my inverted index, it's going to map back to my MongoDB documents. Manchester's in documents 1 and 2, and United's in documents 1 and 3. We have lots of different analyzers that you can use, standard, simple, keyword, white space, etc. We have over 40 different languages, English, Korean, Japanese, whatever you need. And then you could also do custom analyzers. So you can tokenize your data as you wish. There's lots of flexibility there. Now, it's really important. Each of these is going to cut up your data, tokenize your data in different ways. And it's really important to use the right analyzer because it's important to get the terms right. So let me show you an example where I found out this didn't work. So in this application, let's say I wanted to look for players from Manchester United. And if I were to use the standard analyzer, you see that I have 697 players. I don't know if you could see that. And the reason is I have players from Manchester United, Manchester City, I'll have West Ham United, I have Leeds United. Any team in my database that has either Manchester or United in it is going to show up in this result. However, if I change it to the keyword analyzer, look for Manchester United with the keyword analyzer, it's going to match perfectly. I'm just going to get teams from Manchester United. And you can see facets. I have facets here as well, how they're distributed. So, again, with the keyword analyzer, it does not do anything. It keeps your punctuation, keeps the casings. All of these have their own rules. So keyword analyzer will just keep it the same, and you'd have to match perfectly. So they're really good if you have checkboxes, etc. So we know that Apache Lucene works great for search, and we know MongoDB looks great for databases in general. So what we saw when we were working with customers who use MongoDB for their workload, and then they also needed another system for search. They could use some native commands, operators with MongoDB, but they turned out to be cumbersome. So a lot of our customers, users, they had MongoDB, and then they had another third-party system or service, and they would have to keep their data in sync across that. And then they'd have these two different systems. They'd have to scale them and secure them. It came up a whole bunch of problems together, and then it's really hard to keep data in sync as well. But we know that they're using Lucene on the back end. So with MongoDB, we just brought Lucene directly into MongoDB Atlas, which is our database as a service and data developer data platform. Do any of you guys use Atlas? Are you familiar with Atlas at all? Okay, great. Well, I'll show it to you in a little bit, but we have some nice free tiers if you want to sort of play around with it. So, how do you search for data? Now we've set up now we know our first kind of rules. We know kind of the rules of the game. Let's start searching. So what are the rules of the game now that we have a few players? You have to have your data. Of course, we have our data in Atlas. I'll show you. We have to create the search index that I mentioned, and we have to query via $search. So I'll go back to query via $search in a second, but let's look at the data and how we create that index inside of Atlas. So in this data, this is my Atlas cluster. I'm on a free tier, by the way. I don't even need a credit card for that. I have a lot of sample data, and then this is my data for my soccer players. I have 19,000 different soccer players from all around the world from this particular FIFA dataset. Hello. And all of this has different types it has dates and strings and numbers, and all of these things we'll be able to query across soon. I'm going to go to search indexes, create the search index here. 2 ways to create it. I'm going to use a visual editor because it's sort of guided, nice way to get started. We're going to keep default, make sure I'm on the right collection. Now, a couple things I want to point out here is that I'm using the Lucene standard analyzer. I can change that pretty easily with a click of the button, and then I'm mapping dynamically. And I'll speak more about what that means in a second. Create the index and close. Now, I'm creating the index, which means that it is going to map across all the fields and all the documents in my collection. So mapping dynamically is simply how we define those fields. So if it's a string, it's going to be defined as a string, etc. But the nice thing about it mapping dynamically is that it can change as your schema evolves. If you're going to embed objects in different fields, it's going to listen for those changes, and it's going to map that data automatically. So you don't have to kill your index and recreate the index every time you change your schema, which is nice. So now that we have that, the next thing we need to do, the last thing we need to do, is we need to query via $search. So $search is a stage in the aggregation pipeline. If you're using MongoDB, are you familiar with the aggregation pipeline? Who uses the aggregation pipeline? Okay, it is awesome. The aggregation pipeline is a really great way of working with data. It can give you some good analytics. It can transform your data. I use it often to clean my data. I use it to create other collections. People use it to unlock different workloads. Time series can be done on this as well. So in an aggregation pipeline, you have your original documents, and they get transformed every stage. And the result of that stage is fed into the next stage, and so on until you get your results. So if you're familiar with the aggregation framework in MongoDB, that's great, because it means you now know everything you need to know about building search, because search queries are simply an aggregation stage where $search is the first stage. So let's go ahead and build this. Let's build our first query. Now I can actually do this inside of the Atlas interface by going to the aggregation pipeline builder here. You could also do it by hand. Lots of people insist on doing it directly in the shell because they know all the operators, but I kind of like using Compass. So Compass is a graphical user interface that we have for the collection. So here's my players collection on that data, my 19,000 collections. I'm going to go to the aggregation pipeline builder. So my first stage is search. Nice, it has nice autocomplete, so you can type things in really quickly. So inside our search stage, the first line is for our index, which we name default. Then we're going to use the text operator to query for. Does anyone have a player they want me to query for? I'm going to stick with Mbappe because it's actually a common mistake. So I'm going to look for Mbappe over the short, actually. Over the short name field. And you could see just like that, I created the index and I looked all through my 20,000 players, 19,000 players to find Kylian Mbappe. Now, I am a big fan of his, so I know he has an accent on it, but if I didn't know he had an accent on it and I would look for it, I would not find anything. So this brings me to my first bit of trickery, fun things that you could do in your search game is fuzzy matching. So we're going to put fuzzy matching. This comes up a lot in search because people don't know how to spell things, or they don't know how to, or they have typos. So adding this one line of code, you can see in the preview panel that now I have lots of players that are almost like Mbappe. I have Hape, I have Mbaye. And so adding this one line of code enables fuzzy matching so that you can forgive your users for their fat fingers. I'm setting a max edits 2. I can set it to max edits 1. And I have less freedom with that. So if I were to, so now I have my first stage of my pipeline. And again, these results go to another stage. So my next stage is, so I see I have about 100 fields in this document. I don't need all those fields. I'm going to simplify my payload by using project. So let's use project. And I'm going to use get whatever fields I want. Just going to do this one for now. So now I have everybody only by their first name. And here's my second trick. I'm going to do score. I'm going to use the meta operator to surface the search score. So this score, I don't know if you could see that very well. So there's a score associated with every document, every player that we have. Score is really important in search. We keep score in search. It matters. This is based on relevance. Relevance is all good search engines will grade all your documents based on how well that document matched the query that I had for Mbappe and the short name. So here, Kylian is first because he's got the highest relevance score. I was closest to it. But the other ones that show up, the score comes down in descending order. So what that means is that the first scores you get are the most relevant for it. So they're probably the best matches. And because they're the best matches, you get the best matches first. We can add our last stage, which is limit. If we get the best matches first, I'm just going to limit to maybe the first 6 players. So limit is really important in search because speed is really important in search. Performance is so important in search. If you know you're getting the best matches first, then just stop when you get the first. You don't have to worry about the rest of the collection. So now that I have these 3 stages, that is basically all you need to do to run these search plays in your application. So now inside of here, and you don't have to use this, you could write it out by hand if you want to, but we have these nifty tools. You can save your pipelines in here, play with them. And then I'm going to, now that I've built it, and I can see that it's correct in my preview panel, I'm just going to export the pipeline, and then I can capture these 3 stages written like that. That's the heart of my search engine. So now we talked about relevance scoring, so it's really important. And we talked about our basic Atlas search query. And inside, now we can talk about different operators. So operators we use text in that one, but we have lots of different operators that you could use. You could use range, you could use text, you could use phrase, depending on what your data is. This is all going to be custom. So one thing I want you to leave here today is there's a lot of room for customizing your search results. You want what your users want to be surfaced to them first. And you as a search engineer, you're not really an engineer. You're kind of like a search artist or you're a search coach, I guess. Like this is why I'm giving you these strategies to play with. So these different operators are the different ways you can enable your users to find what they're looking for, to serve it up so they can win at the search game too. So every user has a different style of shooting. So it's nice to have a lot of these different options, and with Atlas Search, it's really easy to incorporate these different types of operators in there. So now I'm going to go back to this demo. I'm going to show you a few more things. So let's pick a player for here. Does anyone have a favorite player? Tom, do you follow soccer at all? Just football?
I hate soccer, sorry.
Somebody's got to know somebody's got to suggest a player.
Bayet, A-Y-E-T.
Bayet?
B.
P? P?
A.
Okay, so as he's spelling, so I'm using text, which I can do, but I could also do, actually, he doesn't even need to get to the end. Let's see if I can just do this. So I have autocomplete. So P-A-Y-E. Is he showing up yet? So here he is, Dmitry Payet. So you can see here in this application that I also have, thank you very much. I'm going to look at him in a second. So I also have the code I created another index for autocomplete, and then I have the code for these as well. So I have autocomplete enabled with this API. I can look at this player if I wanted to see, if I wanted to learn more about him. He's from France, he's from Marseille, okay, and he plays. So these are like all the things that I didn't know about him. But if I wanted, I also have this code that's going to find other players based on it. So we also have a more like this operator, which will look for these terms in their scouting report. their style of play, and it's going to look for similar players, not including that player. And so these are those players returned on that, and there's also functionality for that as well. Did I add him here? Let's see if I get P-A-Y-E-T. And so now I've added him to the team. I guess he really should be here, but that's okay. We'll let it go. And then another interesting one that I like to do is, see, how much time do I have? Another interesting one that I like to do is wildcard. So let me get rid of this player. So I was somewhere and somebody asked me to find Szczęsny. I'm sure I'm saying it wrong. I've said it a million times. He's a Polish goalie. So if I was looking for this player, and there are a couple ways I could do it. So if I were to do wildcard, I think it's a S. I'm going to do star. I'm going to do Y. He might show up first because I follow him a lot, but I can see that he's there. So I can look for him and I can put him there. But if I wanted to, let's see. So that's one thing. And so here's wildcard. So here's the code for that. It's, again, the rest of the pipeline's the same. This is just the search stage. Another way that I could query him would be if I were to look for a certain player, like I would look for Polish goalkeeper. So each of these, by the way, so this is my first query. I have text. I'm looking for Poland and the nationality name. But I can start querying because I have that dynamic index that's across all fields. I can start querying for different ways. So now I'm looking for goalkeeper in the player position, and I can do overall. This is their overall FIFA score. And you can see that each of these contributes something to my search, and then I can combine all of that here, because now my search stage uses the compound operator, where I can put in all these different search building blocks, I guess. So I have these compound plays that I can do, and I can sort of emphasize or less emphasize each one of them. So I have search, I have compound. Now this could use must not, should, and filter. And it's really up to you to know which ones you want to do to get the best search experience. Must is means that if I had something in here must, so the range of 60, it means it's very important for it to have it. It's going to contribute to the score. If I have filter, which I do here for, he has to be from Poland. Filter means it's like a what is it called, Lauren? Match. it's like the match operator. It means it's in or it's out, but it doesn't contribute to the score. Should contribute to the score a little bit more, and then must not also contribute to the score. So we have those 4 different things. And so it's kind of, I call them search building blocks. Maybe it's like pieces of a sandwich. And then these must not, should filter depends on, what you want to emphasize more or less. Again, this is kind of the artistry. So it's like how much cheese or meat or mustard you put in your sandwich. So did I add him? So let me add him here. Now, who does not know? I haven't put him here. So let's see. And there he is. So again, I have only goalies you can see, and then I can see which ones are really good. So I'm going to go ahead and add him to the team. So who in here does not know soccer at all and wants to go? I won't call on Tom. Who here wants to play? We know a couple rules. We have some of the rules of the game. We should get ready to play. Don't be shy. Tom, if you went to Tom's talk today, he talked about not being shy when you want to share. So in the spirit of that, somebody come up. Could you come up, sir? Right here, yes. Okay. Thank you. Just humor me, thanks. What's your name?
Konrad.
Conrad.
Yes.
Nice to meet you. So I would like you to play the search game. Do you follow soccer at all?
Oh no.
Where are you from?
From Poland.
Oh, it's like I manifested him. Okay, so let's find. There is a player that I like for. Let's look for this position, and he's Turkish. He's a Turkish center back.
What? Turkish what?
He's a Turkish center back,
Thunderbug?
and his name is Charlar. Charlar, I'm probably saying it wrong, Xianju. That's fine. Now go ahead and hit enter because you're not going to get anything. But, you got things that are close that match because of the fuzzy matching, but we don't have Charlar Xianju, and these players aren't there. But what you know about him is, let's go ahead and reset it. Actually, now that I've reset it, I got to put them back here. So, but you do know a couple things about him.
That he's from Turkey.
That he's from Turkey. And that he's a center back, I think. So CB?
This one?
Yes.
Okay. I don't know the position.
That's good. And then just go ahead and we'll just hit search with that. And actually, so we see, actually, why are they English? Oh, we don't need England here. Let's uncheck England. Let's put, don't know how England got. So now we only have Turkish players. Doing this.
Probably it's he.
It's probably him. Yeah. So go ahead and hit the star. Now you've added him.
Cool.
So we've seen a few things. We saw wildcard autocomplete. I've got one more for you.
One more.
Faceting. Oh, and by the way, faceting is interesting because we have Turkey. In this one, we have Turkey. We have center back. So you can see how those results are distributed here with facets. And if you want the code for facets as well, I actually put it here just so you know how just so you see how it is. It's very similar to the original query, but then we just have some things to do to variables for the counts. So you can see you're doing these searches. Conrad?
Yes.
It's not a very Polish name. You're doing these searches, and then you can see how you're kind of honing in on exactly what you want. So we found him. I've got one more. I'm not a big fan of this guy, but he makes for a good story. So I'm going to take Messi off for this. Do you know Ronaldo?
Which one?
Well, that's a good thing. So let's look for Ronaldo. So and go ahead and hit enter. So we all know the Ronaldo that we would want on our dream team because it's our dream team.
Okay.
But there are lots of different Ronaldos, a very popular name. And we get this result first. This guy, I'm sure he's a very nice guy, but that is not the Ronaldo that we want on our dream team.
His score is low.
Because his score is low, his overall FIFA score is low. So you see, in this, it really is like I've manifested you to be my first assistant. But I want this score to actually influence that relevance score. He's showing up first because he has the highest relevance score. But I want to surface who has the best FIFA, which Ronaldo has the best FIFA score. So I can take this in my function. I can take this field and add it, or I can multiply it, or I could log it, or whatever it is. I could do mathematical operations to any field in my data and have that affect my relevance score. So why don't you go ahead and hit function score for me, please?
This one?
Yes.
Okay.
And then you can see that I've got Cristiano Ronaldo first, and now his score goes way up. So this is his score right here, the 93.41, his relevance score. It goes way up now because I'm factoring his overall score. So this is, he's really difficult, but we'll take him on the dream team because, maybe I won't take him on the dream. Maybe that was a sign. So thank you very much, Conrad.
Thank you. I kind of get distracted when I work on this because I'm like, who are the best English, who are the best English strikers? And then I'll search. And then I'm like, okay, and then I can just do function score and then, function score was already set. So then I can, actually, let me turn it off. Let me reset the whole thing. So if I do, let's do Spanish. Spanish players, Spanish right wing. So I get all these different players. It was using filter. The command uses filter. So it means that it's not contributing the score. That's why everybody comes back to 0. But if I want, and that's up to me, I could have used must or whatever. But if I use function score, then I can find out, then it ranks everybody. So I can figure out who's the best to use. Okay, I've got 13 minutes left. I'm going to go quickly now. We use the compound operator, so we saw how to use different operators in search, and then we show how to combine them of different combination plays, how they can work together. We showed some trick plays with the function scoring. Now, we also have other different types of function scoring, but it's really of score modifiers. So function scoring is a type of score modifiers, but we have other kinds. And it's important to use different score modifiers because research has shown that people don't really go past the first 3 results, and nobody really goes past the first page. So you really want to make sure, to be a good search artist, you want to make sure that you're getting the right results to your users, so they're going to be coming back to you. So these score modifiers, in addition to constant scoring, we have boost and constant. And these are great for sponsored searches if you have sales or promotions or anything like that, or weighting certain fields if some field has more value in it. So that's another way that you can be weighting the field differently. You can say if the result is found in a plot field, then you can multiply it by 3 or 20 or 100 or whatever it is that you wish. Okay, so this might sound like cheating. I was like, that doesn't seem right. But it's not cheating if everybody can do it and they don't. So really use everything. It's very easy to use all these things that you have at your disposal. So now I'm going to talk about architecture. You can't talk about playing the search game without talking about performance and how to play it well. So this is what happens in the life cycle of a search query. The client is going to send to MongoDB. If you're familiar with MongoDB, MongoDB is it's a process on a node, and every query goes to the MongoDB first. So it's going to send it to MongoDB, and MongoDB is going to see that it is a search operator, and it's going to send it over to MongoT. So MongoT is what houses that inverted index. MongoDB is the balanced B tree. MongoT is that. MongoT is going to process all of the search operation that you had, all that entire search stage, and then it's going to return to you just the underscore ID and any relevant metadata, whether it's highlights, frequency, scoring. That would be, so it's really, really tight packages that sends back to MongoDB, and MongoDB is going to take that, it's going to look up those values by that underscore ID, it's going to finish the aggregation, and then it's going to send the results back to the client. So what this means for you is that as you're doing this, it's really important to move, if you're doing search queries, to move as much as you can to that search stage as possible. If you can do a filter instead of a must later, that'll help your performance, because you want to sort of narrow down on only the results as high early as possible, so you don't have to do the lookups. So a few performance tips. The other thing that's super duper important is indexes take space. Indexes take space. When I created that default index, I said just map everything. But I don't, and that's usually what I do when I develop. But if once I have my application working and I know what fields I want to send back on, I know what fields need to be indexed, I go back with a scalpel and I cut out, like, I only index the fields that I want with specifically the analyzers that I want. So we want to make sure that we're doing exactly, it's a scalpel. We want to be really good at this, so we need to run these things with military precision. Custom analyzers you can use too. Your score is already sorted. Maybe this is obvious, but I talk to a lot of people and they're always sorting, doing the sort stage after. In the aggregation on score, it's already sorted, so you don't want to run all those documents in your working set again. Avoid different stages if you can move everything up into search. And then we also have something called a stored source field. So if it's a field that's not in your search query, but you need it, you want to kind of keep it as part of the index, you can use stored source field. If you're interested in that, I can go in more detail later. So if I can leave you with a few things, I've got a little bit of time left. Data, think about when you're playing the search game in order to play it well. Think about your data. Think about how people are going to be querying it and what you anticipate your tokens to be. So knowing what these tokens are going to be, you can think about what your analyzer is. Pick your analyzer according to what you think that's going to be. Your analyzer is specified upon index creation, and those indexes you can have many different indexes. Pick the right index for that query.
And then once you do that, you can serve up search really well for your users. This is your user. He has all the different operators. He has the right analyze, so he's going to be really happy here. Now, if you scan this code, I'll give you the slides later. This code is going to take you to my final little gift that I have for you. It's going to take you to something called atlassearchworkshop.com. So in this Atlas Search Workshop, it's an app that I put together that's going to help. It's like a tutorial on how to build this movie application. You're going to be able to build this movie application much like Atlas Search Soccer, but every lesson has a blog, it has helpful GIFs, it has cut and paste code, options to learn, and the nice thing is, let's see if is that we also have code sandboxes here. So it's ready for you to fork, or you can use it here, so you don't have to worry about any sort of dependencies. I tried to take out a lot of the friction there. So if you do this, you just need to build the endpoint with the search stage, and then that'll work. I show different operators, and I show how different operators are going to get different results when searching this movie set. So this movie set comes on Atlas. It's in the sample data set for Atlas. And then in this application, one thing I have on the end, I have resources. These are some other applications that I've written that do different, if you want to use geospatial search, for instance, you could try Atlas Search Restaurants. I have the soccer one. I have the Git repos for them, video tutorials, and then I have Atlas Search indexes. If you want to learn more about indexes and analyzers, you can try that one. So the nice thing is about this tutorial is it's a new type of tutorial. It's not just reading. You get your hands on the code. So we covered a lot. We got about 5 minutes left. I want to answer all your questions, but we covered a lot. Thank you very much. Fuzzy search, autocomplete, highlighting, multiple data types. I didn't cover highlighting, but that's one thing. Custom score modifiers, filters, facets. Hopefully I can put in synonyms, but it was hard because I've got, I don't know, Zizou. That's the only synonym I know in soccer. So anyway, so thank you very much. I really appreciate it. I am ready for questions if we got about 5 minutes. Thank you.
Hi.
Hi.
Yeah, thanks for the talk. A quick question. I think you said it, but I just wanted to confirm. The analyzers can be changed on the data, so you don't change the data. You can say, okay, this one used to be, I want to cut every single word, but now I actually want a keyword. It's very easy to do.
It's very easy to do. Now, you can either create a different index on it that uses that analyzer, or you can create, you can just change it, and then you can, of course, customize it. Yeah. So if you change your index, it would be very easy to do, and you just change it, put the wrong one, put the different one as the first line in your search stage. Thank you. Yes, sir. The analyzers, I just want to get out. It's actually, I've made a big deal about them, but they are really important because I can teach you all the strategies to find what it is that you're looking for, but sometimes you're not getting the results. And if you're not getting the results, then maybe it's because the analyzer isn't cutting it in a certain way.
Thank you for the presentation. The format was really, really nice.
Thank you.
You showed how to create a search index.
Yes, sir.
How the search index is kept in sync with the data? And how can you change it when you decide to change an analyzer or stuff like that?
So it listens to, so they're actually on the same process. So they're on the same node, the MongoT and the MongoD, and it listens to changes in your data. We have something in MongoDB called change streams and triggers that it can listen, and if something changes, once that index is created, it's going to map it automatically. Was that the answer? Is that the question? Okay. Sorry.
Thank you. So on the demos, you have the Dropbox, right, with the 3 options for how you search. Mm-hmm. In a production application, how do you decide which one you feel is best? Just by like testing the result sets, or do you leave those options out
Yeah.
there? Or?
So it's actually interesting. You obviously you would test the results set. Like I said, you are an artist, and this is something I talk to people at IKEA or whatever, and they're all kind of, they go in and they create something, they paint something, they step back, and they look at it and they go, maybe this isn't right, and then maybe I'll do something else. There is a way that you can sort of say if it has a star, maybe use wildcard or whatever it is that you want to do, but it's really up to you to figure out. There's going to be sort of a feedback loop to sort of, craft it. And was it Da Vinci who said that you're never really done with art, you just abandon it? So at some point you're just going to have to ship it. Thanks.
Thank you for the talk.
Thank
You
you.
mentioned that indexes take space. I'm wondering if, like in relational databases, indexes also impact the performance, like say when inserting items.
Well, relational is hard for a variety of reasons, and I probably don't know all the reasons, but one thing is that it's really hard to store this unstructured data in a relational database. The other thing is they don't know, because a lot of their fields are spread out, you have different tables and they're stored in different places. A query is going to have to go to look across all those tables because it doesn't know. But in a document database, all those fields are in the same document. So it'll go to that document and it looks there. So it doesn't have to do all these crazy network reads across it. Thanks. Yes, sir.
Yes, thank you for the talk.
Thank you.
You talked a lot about the search itself, but also regarding the search results, is the score the only factor giving you feedback about how good the result was, or are there other options?
How good the what was?
The result of the search. Or are there other options that give you feedback about what kind of mutations did you do to the query or stuff like that?
The score is the only rule that levels in what results you get in what order. So it won't actually say how successful your query is. The way I guess you could judge it is how many people bought whatever it is that you serviced to. So, but that's kind of the nice way that you can modify these scores and play around with these scores a lot. So, thank you. I'm going to be here for a little bit if anybody wants to stay and chat, talk offline. Thank you guys very much for coming. I really appreciate it.